Good morning, everyone. Thank you for joining us. Just to check everything's working, you should be able to see me and Steve Mellor. Can you just give us a yes if you can see us? Steve, some feedback coming through yours a little bit. Can you turn your volume right down?
Yeah, I was just trying that. Is that any better?
Yeah, a little better.
I'm struggling to see the chat, but I guess you can see that.
Yeah, I can see it.
Are you ready to go, guys?
Yeah, I think so. Morning, everyone. My name's Pete Ashcroft from Sygma Solutions. I'm joined by my colleague, the legend that is Steve Mellor. So if you've joined us on these webinars before, you'll know that we're quite new to the software. We've run a couple already. This is the first one we're doing as a double act. So anything can happen when Steve gets in front of a computer. So bear with us. First time as a double. We'll see how it goes. A few intros first of all. I think I recognise some names. So I think you've joined us on these webinars before. Sygma Solutions, we're a training provider in utility locations. So we do kind of Cat and Jenny training. We run the 5-day utility mapping course at the survey school, the PAS 128 course. And what we're running for you today is a little snippet of that. Really, it's a section taken from our 5-day course, which Steve runs, and he's going to be delivering it. My background, just very quickly, guys, I don't want to bore you. I think some of you will have heard it before because you've been here before. I started Radiodetection over 20 years ago now. And interestingly, Steve Mellor is the man that gave me the job. So he was my boss at Radiodetection.
It's my fault.
Yeah, and he taught me everything I know. So Steve mentored me from the age of about 19, 20 as my boss at RD, and it's brilliant that we work together now and stuff. So I'll let Steve tell you very quickly about his massive background. So over to you, Steve.
Thanks, Pete. Yeah, very quickly, guys, if you've never met me, I started in this business this year 43 years ago. I know I don't probably look old enough, but at least we've got the same airline, Pete, now.
Yeah.
Yeah, I started as a surveyor working in my dad's company. It was a franchise organisation which was started by Radiodetection. It was called Electromagnetic in those days, back in the 1970s. And so I just started tracing out buried services with the old man. Electromagnetic became Radiodetection. It changed from a surveying company to a manufacturing sales company, and we went along with it. So sad admission, I know, but this is all I've ever done. Locate buried services all over the world, train people how to use it, help develop equipment, bump into lots and lots of friendly people, and that's a very brief background as to what I've been doing for the last 40 odd years.
So there you go. That's us, and that's a bit about Sygma. Just a little bit on the software. It works pretty well. What does happen is there is a delay. So you'll be hearing this probably about 10 seconds after we say it. We're trying to make the sessions interactive, so we're going to be asking questions. The problem with that is that because of the delay, it takes us 10 seconds to get the answer. So it means there's a few pauses throughout the presentation. We'll have to ask you a question, and we're kind of going to wait till we get the answer. So please just bear with us on that, guys, if it does feel a little bit disjointed at times. So the section we're going to cover today is based on the high NDM stuff, multi-frequency locators. So in particular, we're looking at 8000, 8100, and the vLoc series, but it's applicable to a lot of the high-end locators. It's good to see on the poll that most of you have had training before, because this is aimed at a bit of a higher level. We're going to look at frequencies, distorted fields, connection techniques. So there's going to be quite a bit of stuff we're going to look at today. So without further ado, I will hand you back to Steve, who's going to start off.
Thanks, Pete. As Pete mentioned earlier on, this is part of, this is usually my day 3. We've already covered a lot of stuff about electrical theory, networks and things like that. So the guys would normally be moving into understanding about how the kit works. And I'm guessing a lot of you guys out there already know a lot of this. Maybe just a refresher for some of you guys. There might be some pointers, some ideas. I can't see the chat for whatever reason. We had a bit of a disaster just before we came on air. The server seemed to go down, so we were struggling with actually getting online. But anyway, this is my first one as well, so be gentle with me. I've never done this before, apart from a very quick run through with Pete earlier on. So,
just on that note as well, guys, I am monitoring the chat, so any questions whatsoever, just fire them in the chat, and I'll throw them at Steve as we go through. So please do get involved, guys. Keep it interactive. Chuck some stuff in the chat, and I'll challenge Steve with it as we go through.
Problem number one is trying to advance to the next slide. Bear with me 2 seconds. So first thing we're going to cover, guys, is active signal application using a transmitter. I suppose technically there's 5 different ways of doing it, although this only shows 4. We've got direct connection, signal clamp, although not a lot of people are familiar or maybe not use the plug connector. It's an option. And then induction. The 5th one that's not on there is live cable connection, which most of the manufacturers still offer as an option, but probably hardly anybody uses that nowadays. I'm guessing most of you guys will be using the first 3, 1, 2, and 3, direct connection, signal clamp, or sorry, 1, 2, and 4, induction. The only time a plug connector might be useful is if you're working on, let's say, somewhere like a military base where you've got a lot of outbuildings and you need a quick way of working out where the LV supply to the building goes to. It just means you can nip into a building, find the nearest plug socket, plug it into the transmitter, into the plug socket, switch it on, and it's just a really quick way of being able to trace out. It's not my favorite device, but it's kind of useful sometimes. So everybody knows this. It's always considered best practice. We'd have already covered about how the transmitter works in various signals in the previous days on the surveyor course, learning about AC and DC. Technically, it doesn't matter which way around you connect the leads, but with things like the top end bits of kit like the TX10 and the vLoc series equipment, it makes sense to connect it up as shown. Red lead to what you're trying to find, black lead to an earth. Obviously making sure it's safe to do so. This old technique has been around as long as I can remember. I won't mention the fluids we sometimes had to use for earth, but you can kind of get the idea. So you've got, in this scenario here, red lead connected onto a gas riser going into a property, and it doesn't need to be any posh mineral water, just any old water will do for an earth. We normally get the gas lads who are used to doing the Cat and Jenny courses questioning that slide. If you've done Pete's course before, you'll understand. If you've done training with us, you'll realise that that's not actually tracing out gas. That's a technique we use for tracing out electric. We'll talk about that a little bit later. But if you're ever struggling for earth, that's what you can use. Water on a wet day, stick in a puddle, something like that. I've lost Pete from this. I don't know where he's gone, but I'm guessing he'll come back sometime.
I just turned my video off so I could have a little vape on the vape. That was all.
Where you go?
I'll pop in every now and again when you need me. So
again, I don't know how many of you guys have done some of the other courses with Pete, the webinar sessions with Pete, or if you've done courses with us before. It makes a massive difference where you place your earth as to how your signal travels. There's one thing which is missing on this slide, and I'm just going to quickly draw it in. So all these arrows are showing one direction. There's probably a song there, but I won't bother. If you've done my course before, you'll know that that'll gain you an extra point when you draw it all out. This is an AC signal that we're actually transmitting down a pipe. So AC doesn't have any actual direction, so the arrows should be double-headed. So your signal's going to be going in all kind of different directions, and of course, where you place your earth affects that signal flow. We're going to do, I think, possibly a section on basic electrical theory, maybe on a different webinar. But understanding how electrical circuits work helps you understand what your transmitter signal's doing. So if you place your earth close to another service, adjacent service, that is going to cause your signal to actually transfer across into that. There's also a function of frequency, which we'll cover a little bit later on, but you do need to think about where you put your earth. Pete, in one of his previous sessions, asked people with a cat and Jenny course where to place the earth. You'd be amazed at the number of people who said at 90 degrees or as far away as possible. Going back to the old days of the cat and Jenny and even the old RD kit, one of the main reasons for that was the transmitters didn't have very good impedance matching. And if you kept your earth fairly close, you didn't get much of a signal. So the further away you moved your earth, it actually gave you more of a signal. Nowadays, with very good impedance matching, a lot more power, you're better off keeping your earth as close as possible in most cases. There are exceptions to that rule, but so in this scenario here, we're using the actual metal frame around a lid for the earth. So you're connecting onto a valve stem on a pipe, metal pipe, using the metal frame for an earth. That is reducing the amount of power which is actually being transmitted generally, or it's localizing it, shall we say. But it's reducing also the amount of cross induction or cross coupling, as they call it, onto other pipelines. Again, this is a possible function of frequency, but.
And just to jump in there, Steve, we touched on this. If anybody here was on the Jenny session today, we touched about this kind of myth that more power is always better. You know, like Steve said, getting your earth far out, shoving it in and whacking a load of power down there. It's about understanding that power and controlling it really, rather than just automatically thinking more is better. Would you agree, Steve?
Absolutely, yeah. In the good old days, the kit we used to use before most of you were even thought of, less was better. We would turn the transmitter down as low as possible. Bearing in mind we were using analog kit in those days, which I know I'll be accused of being an old fart, but the analog kit was miles better than the modern digital stuff. I'm sure the manufacturers might not agree with that, but we could turn those things down so low that you almost had no signal. And again, a lot of people think that more is better nowadays, so you're getting more signal, you're getting a better trace. That's not always the case. I'm not able to see any questions, Pete, so I'm guessing you're monitoring.
Yeah, I'm monitoring. Don't worry, there's no questions in just yet.
Nobody's asleep just yet? No.
Yeah.
The other main issue is if you can't get an earth, any kind of drainage type metal lid is ideal. I say drainage because you don't want to be earthing to a comms or electric link box lid or something like that, because you're going to energize the lid and then possibly energize the cables below it. But there's things in drainage that you can't energize, not unless you guys know something I don't. So a drainage cover lid, a gully cover, a road sign that's not illuminated, anything that's sticking out the ground if you're struggling for earth will suffice.
I think you've even used a tree before, haven't you? I'm sure.
I have used a tree indeed, yes. And I've got some very strange looks when people said to me, why are you using a tree? Because it's not conductive. Well, when you think about it, a live tree is, because it's full of moisture. We were using high frequency, but yeah, a branch on a tree will give you an earth. It won't give you a very good earth, but it will give you an earth, because obviously the tree's in the ground, the roots are in the ground, and it's fairly moist. The other thing to say, and this is just something that I'd normally cover on the course anyway, and we do it in the practical, but with the TX10, to save battery life, it always defaults to low volts. And every time you switch it off, it defaults back to low volts. So if you want to get more power out of it, you've got to go into the sub menu. And as you scroll around the sub menu, I can show you guys if you want, but to access the sub menu, you press the on off button, which puts you into menu mode. You use the arrow keys and you scroll up until you see max V. You set it to max V, and that will give you a lot more power if you're really struggling.
Daniel, just on the question you've just asked, Steve, Daniel's asking, was it stabbed into the tree or just looped around it?
It was just literally clipping onto a branch. So take the black lead and just get the jaws to chew into the branch itself, if that helps.
Not that you're encouraging people to damage trees, Steve.
Definitely not. No. I certainly wouldn't stab trees with earth pins. And the other thing these earth pins have always been that sort of L shape, although that's got a triangle on the end of it, because you can actually put that in at this sort of angle. So rather than hammering it into the ground with a lump hammer, you can stick it in like that. So if you imagine that's just an inch or two into the ground, and you've now connected on there, there's your earth pin sticking out of the ground, and you're just putting it horizontal. You're going to get the same earth contact that way, horizontally, as you are vertically, because you'll always have some smart person saying, did you cap the area before you put your earth pin in the ground? So
I'm just going to mention that, Steve. I get it quite a lot with the Cat and Jenny training. We're clipping onto a column and putting the earth pin, and you get some people jumping up and down saying, you didn't scan it before you put it in. I say, well, hang on a minute. Why am I clipping on the lamp column? I'm clipping on the lamp column to bloody find it. If I could find it without clipping on it, then I won't be clipping on it. So, scanning the ground to see if there's anything there before I stick a pin in isn't actually going to tell me there's nothing there. So, like you said, putting it in an angle, it's about the surface area of the pin being in contact with ground. Just under the turf or something is what I often do with it.
yeah, I'll just lay it on the surface, pour a load of water on it, or anything else you happen to have around, tea, coffee, soft drinks, just anything wet. I have used a fence for an earth before. I certainly don't recommend it. If it's a very short length of fence, then you can probably get away with it. The thing to remember about when you clip onto a fence, if you trying to use that for an earth, this is an AC signal, remember. There is no direction to it. So your signal is going backwards and forwards, up and down your two leads. And if you clip onto a fence, you've now created one whacking great induction aerial. So that's one of the main reasons you don't really want to use a fence. The picture on the right is showing something like a feeder pillar or cabinet. Again, there's a very obvious reason for not using that. AC signal, you've got no idea which signal's going where. So you clip onto your pipe, you clip onto a feeder pillar or cabinet, you're now putting signals down everything. If you're doing a Cat and Jenny type exercise and you're trying to avoid stuff, you might find that useful, but we don't normally recommend it. Independent earth's always better. Earth pin, manhole lid, frame round, valve box lid, something like that. Keep it independent as much as you possibly can. We've been on training courses with guys when they've clipped onto a service in a building and they've gone to use the massive earth for the earth connection. All you're doing there is creating a short circuit. And if you do get any signal going out, it's just going to go out on everything. So again, stick to the earth pin. Or as most surveyors have, the screwdriver, because they lost the earth pin years ago. You might think this is fairly basic, and some of this stuff is, and Pete would have covered this on the Cat and Jenny course. The first thing I'd always say is use a volt stick before you connect onto any street furniture. The reason for that, although it's not very common, an old mate of mine who has got his own surveying company did get a fair old kick off a street light once down in Exeter. Although it's not common, it does happen. You can get street furniture which is live, so volt stick, for the sake of a few quid, could actually save your life. So check first before you connect onto anything metal. The picture there shows the earth spread out at a 90-degree angle away from the column. If you guys didn't see Pete's Cat and Jenny session the other day, there's one very obvious reason why you don't want to do that. As Pete mentioned earlier on, we don't know which way that cable's going. So if I put the earth out as shown in that picture, there's one very obvious area you can't trace it. If that cable comes out at the base of the column and goes this way, we're okay. But as we start walking around here...
Oh, sorry, you're already doing it. So.
You what, mate?
It's all right, you're already doing it. I was putting the whiteboard on for you. Go on, sorry.
Okay. So as you start walking around there, you're going to have a huge, great signal coming off that earth lead. So what we really want to do is keep everything as close as possible. That then means as you walk around that column, you can do a full 360 and now determine which way that cable is going. It could be loop in, loop out, in which case you could have a couple of cables going in different directions. It might be three-way where you've got a loop in, loop out, and then maybe a feed off to a road sign. You might have a illuminated road sign over here somewhere with a light on the top of it. And there could be a third cable coming out here, going off around there to feed that. That could be loop in, loop out. So you may well have signals going off in different directions. You might not find that feed to the illuminated sign. You might have to go and clip onto that. There's no guarantee that when you clip onto something, even though the cables are all connected in there, you're going to trace every single one. You may have to clip onto each one individually. A lot of that's down to which way your signal's going, path of least resistance, earth travel, all that kind of stuff.
And on that, guys, if you've done the Jenny, getting the best out of your Jenny webinar with me, we covered a lot on this, if you remember, about path of least resistance, earth points. So if you haven't done that session, there's a few more of the getting the best out of the Jenny sessions coming up, so get yourselves booked on there, guys. And we go into that in more detail about signal travel and things, and the path of least resistance and stuff.
One of the things we kind of assume on these things is that you guys already use the kit day in, day out. You've done a formal training course. I think one of the questions I think Pete asked the other day, who's actually done that? We didn't ask that today.
I did, Steve. I've done a poll.
Okay.
So 86% of people say they've been trained before, 13%
Okay.
have.
All right.
And I know you can't see in the chat, but I've been asking in the chat what kit people are using. There's a really big mixture there of 8100s, 8000s, and vLoc 3s. So all the kit we expected. So yeah, we're on the right tracks for the kit we're referring to.
Is there anybody using anything different to either RD or VVAX on the poll, Pete? Is that it?
No, it's all 8000 and VVAX, mate.
Okay. As you guys will probably know, and you've probably tried both bits of kit. If you've not tried the VVAX, it's very, very similar to the RD kit. In fact, it was designed by the same engineer, so there's great similarities. Pete and I are completely independent. We don't have any allegiance to any company, so we always recommend the best you can do, borrow a bit of kit and see which you prefer. Going back to connecting, obviously these slides are predominantly showing an RD bit of kit, but the connection is exactly the same regardless of which transmitter you use. So this is showing signal travel. The one thing it's not showing is return, and it's showing the arrows in one direction. So of course the signal, depending upon frequency, is doing this however many times per second. And then attached to this will be an earth mat. And then, of course, we can have signal travel back to our signal source. So this is something we'd cover on day 2 of our surveyor course, which is basic electrical circuits. So anytime you connect that transmitter up, that's what you're doing. You're creating a basic electrical circuit. And the thing that we try and get most of us thinking about is visualizing, where's my circuit going? Where's that signal going? It's not necessarily going down what you want it to go down. You've connected onto a street light column. You've got a cable going away from the column. 99 times out of 100, that's where it's going to go. There may be some reason why it doesn't. And of course, if you started from the substation, for those of you that have ever worked out of substations, connecting on directly in the substation is a complete waste of time. You're going to have to use a signal fan. That's because all those cables in that substation are connected together. It can be useful sometimes when you do get signals going back to a sub. Let's say this is your HV going this way. So you've got 11 kV coming into a substation. Again, I don't know where you guys, I'm guessing most of you guys are from the UK. Our distribution voltage in this country, 11 kV. If you're in the States, unless it's changed since I was there, 13.8 kV, but very, very similar. So we've got a whole bunch of substations out there, 11 kV, transformed down to LV. One of the hardest things to actually trace is the HV. We cover this on bog standard Cat and Jenny courses. Most people think that HV is dead easy to find. If you've got access to it and you can get a clamp around it, that is true. If you haven't, it's so much more difficult. So using a street light which is directly connected from an LV main through a substation, is a way of tracing the HV, assuming the HV is not going the same way as the LV. Other than that, your only real option is induction. We'll cover that a little bit later. That picture implies you're going to trace every cable, which is not true. You're going to get the bulk of your signal traveling down the service to your joint and then splitting off. I don't know how we're going on questions, Pete, if there's anything that people want to ask, or if you're still there.
Yeah, I'm still here. I'm monitoring it. There's nothing coming in. Guys, if you have got any questions at all, any issues you've had with the kit, any problems you've had in the past, just chuck them in there and I'll put them to Steve as we go through. So don't think you have to keep them on topic of what the slide is. If there's anything in particular you want us to cover, then chuck it in the chat as Steve's chatting away. So
the other thing, and as I said to you right from the start, this is the first one I've ever done. So when we do this for real in a classroom situation, I've got lots of props I use to help me. They're in lockdown in Worcester at the moment, so I can't use those props. I've got a bit of kit behind me, but anyway, that chart in front of you is a range of frequencies that, if you look through the whole spectrum of frequencies that you can get out of your RD TX10 or your vLoc Pro transmitter, there are a lot more frequencies than that, but that's a reasonable range from low to pretty high. Again, we cover frequency on another part of the course, which is normally my day 2 bit. The easy one to look at there is the 8 kilohertz one, and if you count the peaks or the troughs, don't matter which, you've got 8 cycles. When I was working with RD and we were going to multi-frequency machines, and the RD600 that Pete had in the background the other day was probably the first proper multi-frequency machine that had 7 frequencies. And we chatted to the guys about explaining about frequency. And the thing with frequency is we understand it, and software engineers understand it, but we just assume that you guys do. So when we talk about low frequency, we're in the hertz range. And when we're talking about high frequency, we're in the kilohertz range. And we told the guys at the time to keep it to one or the other. Just keep it as either hertz or kilohertz, but don't mix and match. So when I start talking about low frequency, I'm talking about 320, 640. In reality, if you want to move that into the kilohertz range, that's 0.3 or 0.6. So when we start talking about 8, 33, 65, we're actually talking about 8,000 hertz, which is actually 8,000 cycles per second. So if you notice the peaks here again, 1, 2, 3, 4, 5, 6, 7, 8. Nobody's counted the rest of these, so I'm not guaranteeing those are actually accurate. But the one thing that this graphically shows, apart from a load of squiggles on screen, is over the same period of time, the amount of energy that's being generated. So if you look at 131, there's a huge amount of peaks within that same period of time. So when you start putting these signals onto things, and the question I always ask surveyors, what frequency do you normally use for tracing? I don't know if you guys want to answer that. If you're out tracing out, what frequency would you normally choose? I don't know what sort of lag or delay we've got.
I'll update you with the answers when they come in, Steve. The other thing that I was just going to touch on here, Steve, while you're waiting for that answer, is for anybody that did the Jenny part with me again, or anyone that plans to do it, is what the Jenny 4. So on your high end stuff where you've got selectable frequencies on your transmitter, for anybody that's used the Cat and Jenny, with the Jenny you've got an on button, and what the Jenny 4 is doing is that's not quite work there, but turn it off. It's using the 131 and the 33 combined. So that's what they do. If anyone was on my session yesterday, we talked about this. So the Jenny 4 is transmitting 131 and 33 simultaneously at the same time. And the simplest way to describe it is when your Cat's on Jenny mode, when you whack it up really high, you'll kind of hear both frequencies, and then as you turn it down, it kind of gives you whichever one's working best. So it's giving you a little bit of the benefits of a multi-frequency locator, but trying to keep it simple in the fact that you don't need to think about which one you selected. So some of the answers coming in, Steve, somebody's put mostly 33 and 8. Somebody's put start on 8 and then change depending on signal. 8 to 33, 33 and 8, 33 and 8, 8 and 33, 33, 33, 33. And interesting, as we discussed before, Steve, there's not that many using low frequency, which I'm sure we'll come on as we go through here.
A little bit later on the session, guys, we're going to cover the very low frequency stuff, CD, SD, if you got VVAX, SIS. The kit that I started with in the 1970s had one frequency, and that was 3.14 kilohertz, if my memory serves me well. We didn't have any other option. That was it. And in the early days, because the components were fairly iffy, we used to have to tune it in to make it actually work properly. And before anybody says, was that in the days of valves? No, I'm not that old. But anyway, the interesting thing about asking people about what frequency they use, there's no real right or wrong when you start talking about using different frequencies. All we can give you is some kind of advice on what the effects of using those frequencies will be, and what will sometimes happen if you're using higher frequency versus low frequency. And don't get me wrong, high frequency is very, very useful. If you're doing long distance tracing, it's going to be low frequency. Look at those wavelengths, because that's how you measure frequency. It's wavelength. It's cycles per second. Before we became European, and if we've got anybody from the States here, you probably still refer to it as CPS, cycles per second, rather than hertz. But 1 hertz is 1 cycle per second, same thing. If I'm boring you rigid, my apologies. But if you've ever been to a gig or any kind of music festival, you'll know this. You can actually feel the low frequencies. So you've got a whole big bank of subs, low frequency subwoofers, and then you've got a whole bunch of tweeters, which is the high frequency stuff. And when that bass kicks out, you can actually feel it move in the air. I don't know if he's watching, but my younger son used to have a car with a sub in the back of it, which I think was more powerful than the engine. I could hear him driving down the road about 300 yards away before I could actually see him, because I could hear the bass going boom, boom. You couldn't hear the song, you could just hear the bass. And that's the same thing. The low frequencies are going to travel a lot further than the higher frequencies. Let's see. Okay. So this fairly basic slide that you're looking at now, this symbol here is the symbol for no earth or capacitive earth. In the UK, pretty much every property now is what's known as PME, which Pete covered on his Cat and Jenny course. There's a little bit more about PME on our course a bit later on. But if you put a low frequency signal onto a cable where you've got service connections coming from it, and there isn't actually a physical earth, you won't get that signal traveling down those services. So low frequency being in the 320 or above, up to about 9.8 kilohertz. If you want to try and pick up those service connections, you can get them usually. There's better ways of doing it, but if you can't get access to the building you're trying to trace to, you can use higher frequency. So this is where the 33 up to maybe 200 kilohertz is more useful. The downside of using the higher frequencies is you'll notice that this one is now also carrying signal. Because of the extra amount of energy which is being generated, you're actually getting a significant amount of cross induction at the higher frequencies. So this is our transmitter, this is our red lead, this is our black lead. So this is basically transferring across. Let's use 33, for example. 33 kilohertz, if you want to be precise, is actually 32,768 cycles per second. So just under 33,000 times per second, that signal is alternating backwards and forwards, which means you're getting a huge amount of cross induction. I'm not saying don't use it, I'm just pointing out what happens.
This is also, guys, where the practical element fits in. These webinars are great, but where we run the courses, and that's why we believe in doing the practical training on a really built-up residential area where we've got all this. And we've got a real example of this, and we use it quite a lot, and there's a street nearby. And when you go to that street and put 8K on the LV main via a lamp column, you only trace the LV main. You don't pick up any of the house services. But if you go onto that same lamp column and stick 131 on it, you then pick up the house services off it, but you don't trace the LV main anywhere near as far. So it's nice to show real examples of that. But it's something you guys can try. You know, when you're out there, try alternating between them just to, and see the differences that you get when you change frequency.
Just going back to what Peter's just said, and the Jenny that he was covering the other day on his webinar. The Jenny's actually doing something, and so is the VVAX Jenny version. They're both doing something that the current kit can't do, and it transmits two signals simultaneously. The old RD600 that Pete had behind him, that could actually transmit 3 signals simultaneously, and I'm slightly surprised that manufacturers aren't doing that again. It meant that you didn't have to actually change frequency. Although nowadays with Bluetooth and remote switching, you can do it pretty easily anyway. But you can actually get a machine which is transmitting signals simultaneously rather than just relying on one frequency.
Can I just jump in again there, Steve, for a second? There's a really good example of that, and this to me is actually the benefit of the lower end kit with the Jenny 4, and that's why I think it's more suited to the guys in the UK that are actually doing the excavation. They're not utility mapping surveyors. But there's another street that we go to, and we put the Jenny 4 on the lamp column again. We get what you get with the Cat 4 is you can actually hear which frequency you're picking up. The tone is different, so you can tell whether it's 33 or 131. So you hook up to the lamp column and you trace the main LV on 33, and you can hear the 33 coming through. But then you pick up the house services on the 131. You can hear the tones different. So on that same scenario, if we only put the 33K on that LV, we'd only get the main. We'd have to then switch to 131 to get the services, if that makes sense. So we've got a switch between them, which for a general operative out there can sometimes be a bit too much to think about. So the good thing about the Jenny 4 and the V-Scan transmitter is because it's doing them both simultaneously, we get both those benefits at the same time. So, and back to you, Steve. Sorry for interrupting.
This is kind of a generalization, guys, but again, what frequency do you want to use? We've had a variety of people saying 833. What we train on and as Pete said, this is a lot more difficult, so we can't actually take you guys outside and show you this, but the advantage of the high-end kit is you've got that big range of frequencies. You don't need all those frequencies, and I always explain to people on the surveyor course, because a lot of people ask, why are there so many frequencies on that kit? There's one very good reason, and it's the US market, which is, I can't explain how big it is compared. I think the last figure I looked at, it was just shy of $1 billion a year. It's a monstrous great market. There's lots of manufacturers out there. There's lots of companies, and that's because of the US legal system where you need to dial 811 before you dig. I'm not going to bore you guys with that today, but so there's companies out there with, one company's got nearly 10,000 people tracing every single day. That means they've got lots and lots of kit. So if you've got a whole bunch of RD transmitters, you don't need to buy RD receivers. You can buy any other manufacturers. We couldn't do that in the days of analog. That is the advantage of digital. In the days of analog, every frequency had its own channel. That was one of the biggest problems of the RD600. Because it had 7 frequencies, it had 7 channels. They ran out of space actually in the case to build the thing. So they had to put the 130 kilohertz frequency into the aerial because they couldn't actually get the circuitry into the box. So with the digital stuff, you've got a microprocessor which, within certain parameters, can give you any frequency you want. So that's what all those frequencies are for. But what you do have the advantage of is having low, medium, and high. So what I say to most surveyors is turn off the ones you don't use on a regular basis, but keep some of those frequencies available, so you've got them without having to go back in and switch them on. So a low frequency, maybe a couple of medium frequencies, and a couple of high frequencies is kind of all you really need.
Just want to jump in again, Steve. I've got a question to ask the guys. In the UK, we tend to class low frequency as 640, but in the US, low frequency over there is 512. And also the STD is different as well. I just wondered if anybody even knew why that was. Just an interesting question for you, and I'll leave you to ponder that while Steve carries on.
So we've got an old-fashioned oscilloscope there showing, again, a sine wave showing the wavelength of a certain frequency. This is a big generalization, but generally we consider that low frequency, you probably consider 9.8 in that as well, will give you a much longer range. I've got to qualify that because you need a lot more power to drive it, and that's one of the problems. People think that when you put high frequency on, you get a really strong signal, which you do because of the obviously the increased or the decreased wavelength, if you like. So the increased intensity of signal, you get a much bigger signal initially, but because of the energy that's using up, it dissipates very, very quickly. But to get that low frequency to travel, you need more power, and that's when you need to go into your if you've got a TX10, you don't need to do it with the VVAX transmitters, but you do with the RD kit. You've got to go into there and put it to max volt to get the extra power out of it if you want to go longer range. There is a trade-off with that, of course. Obviously, the more power you're driving from your transmitter, the quicker your batteries run down. On a surveyor course, I always ask the guys who's usually rechargeables. If you don't, I strongly suggest that you pester whoever buys your kit and get rechargeables. I'm not being paid by any of the manufacturers to say that. It's just a pain in the you-know-what. If you're out on site and your battery's dying, and the rechargeable packs for both sets of kit are brilliant. So if you don't have rechargeables, by all means, try and push to get them. So your low frequency. Go on, Pete.
Question come in. Where does 33 sit on that scale? 33
is in a medium to high range. Although we got low and high, it's in the locator spectrum, you're kind of calling it high frequency. If you look on Wikipedia, if you want to know more about the radio frequency spectrum, these frequencies come into the VLF and the LF frequency spectrum, the very low frequency and low frequency spectrum. These things and 5G, I'm not going to go there. Those come into the ultra high frequency spectrum. So you're in the gigahertz range. I don't know if you guys can see that. Sorry about that. Yeah, so 33 is kind of a medium frequency. I'm not saying don't use it. What we find in this country, and it happens quite a lot near Sygma's offices, there is some switching on cable TV that really interferes with 33 kilohertz. There are days when 33 kilohertz you cannot use it because you're getting so much interference from the cable TV. Nobody seems to know how and why because it's intermittent. But the good thing about the high-end kit is if you're getting interference at one frequency, you change it. Obviously, with a high-end kit, you can also sidestep. You don't really need to do that because you've got such a wide range of frequencies, but you can shift that frequency by a few hertz either way. But so low frequency is going to give you longer range. You get less cross induction. It's much more of a location or an identification, as much as we can call it identification frequency. You get much more signal on induction at higher frequencies. That means you can induce into things like comms cables, cable TV. In this country, most BT services drops to properties aren't earthed. In the US, they are. That's the main difference. Cable TV is earthed because it's going through your cable TV box. That's connected up to your electric supply. That's going back down electric, so that's going down to a PME earth or substation earth. So cable TV is earthed, but BT generally isn't. So that can be quite useful.
Question in, Steve?
Yo.
frequencies with a clamp. Joel's asking, am I correct in saying you cannot use lower than 8K with a ring clamp? I'll let you answer.
You can, but you have to buy a very expensive, very heavy clamp, which I'll show you a picture of in a minute. Both RD and VVAX, I don't know which kit you're using, but RD and VVAX both make low frequency clamps. The problem with the clamp is it's taking a huge amount of energy to actually induce into it. It's a form of induction, basically. I suppose the simplest way of explaining it, it's like a concentrated induction. You're putting that clamp around something, but to make that clamp actually put any signal into anything, you need to have it matched up to the frequency. And obviously with a standard, let's say 4-inch 100mm clamp you get with most bits of kit, maybe 150mm clamp, because we've got such a wide range of frequencies, they're not really optimized. So if you want to put a low frequency in there, you need a much bigger clamp with much more windings to try and get that signal out of the clamp. I'll show you a picture in a minute, but you're absolutely correct. And all the kit blocks out the frequencies it's not able to transmit. So if you plug in a 4-inch clamp, 100mm, 150mm clamp into a TX10, it won't let you select the low frequencies. It will let you select the high frequencies though. Pete mentioned the poll of guys not using nobody mentioned low frequency. Part of what I do besides training is I do a lot of cable fault detection. The first rule in cable fault detection is locate the cable. I've broken that rule a number of times and it's usually caused me no end of grief. So the first thing you need to know is where your cable's going. And I would never go out on a cable fault unless I had a machine that did CD, SD, or SIS. And the reason for that is if you're not sure you're on the right cable, you are completely wasting your time. The thing with surveying is when you're out tracing, if you've got a whole bank of cables, you might not necessarily be tracing the right one, but if they're all going the same way, does it really matter? Probably not. If you're on somewhere, let's say a chemical plant, where you're tracing out different pipelines, that is obviously very critical. You need to make sure you've got the right thing. This is where things or frequencies like SD, CD, SIS are crucial. I'm not saying you can't trace it at higher frequencies. I'm just saying this will give you the actual confidence. I've had stand-up arguments with people who tell me I'm tracing the wrong thing. If I didn't have CD or SD, you're not sure whether you are actually right in standing your ground or not. When you use CD or SD, you can stand up and say, yeah, I'm right, you're wrong, mate, sorry. And I've done that numerous times. So
just want to jump in a second, Steve. Yeah. Ben's just asking CD's current direction, what do the others stand for? So Ben, it's what the different manufacturers use, basically. It's the same thing, same process, current direction, but I'm guessing due to copyright and things, it's just called different on different locators. That's all it is. They just refer to it differently. The other thing that I wanted to add here as well, guys, and we did cover a bit of this on the Jenny stuff, and I hope Steve doesn't mind me jumping in for a second.
Not at all.
And I think Steve will agree. One of the things that I find that surveyors aren't doing, utility mapping surveyors, is taking advantage of this current direction. I see it underutilized quite a lot. And this is one of the very big benefits of the high-end stuff. And this is an issue that we have with the Cat and Jenny a lot of the time. Steve, could you just put me a blank screen on, just a blank PowerPoint screen, just while I quickly just draw something out and show people where I'm going with this. And I know you're going to touch on this as we get through a little bit later.
If I knew how to do it, Pete, I'd do it.
The right-hand side one there, the 3 dots. That's it, click on that. And then screen, white screen.
For whatever reason, this is extremely slow.
Yeah, it's just lagging a little bit. There we go, just click white screen.
There we go.
So this will be good, a bit of background of where Steve's going next with this and the importance of current direction and current measurement. Just to give you a little very simple example here, guys. Just as a plan view, imagine that is a metal pipe, and we get our transmitter and we hook up to it and we earth it here. And then running parallel with this, we've got another utility. So the signal is traveling down here, and as Steve said, it's kind of not coming back. It goes both ways, but just to make it simple to understand, we've got signal on here returning. Now, in theory, because we are hooked up to this one, this should give us the strongest signal, okay, which often happens. And that's what we do with Cat and Jenny. We hook up to something, whichever is the strongest signal is assumed to be the one that we're hooked up to. However, imagine this. Imagine that this pipeline is a meter deep, and this utility here, whatever it might be, is only 300 mil deep. Can you see what's going to happen now? If they were both the same depth, then yes, this would have the strongest signal on it. But as it's deeper, it's not. It's got a weaker signal on it. So we now think this is the strongest signal, and we misidentify that pipe. So that is the problem. So and that's a bit of background, if you like, of where current direction comes in. So with current direction, we can start working this out, and that's what Steve's going to go on to next. So I just wanted to give you a bit of a background of why this is important and why current direction is important. Just while I'm on, guys, is all this making sense so far? It's difficult when it's a webinar. We can't see if you're concentrating, confused. So just give us a yes if you're okay what we're covering and it's all making sense. And again, any questions, guys, stick in that box. And I will pass you back over to Steve.
You can only apply CD through direct connection or a dedicated CD SD, so signal direction, current direction, signal select, clamp. VVAX probably wouldn't like me to say this, but you can actually apply it using a standard clamp using SIS, although they do sell an SIS clamp, but I've used the standard clamp using SIS and it does work. That's a standard CD clamp that you get with the RD kit. The downside is its size. We said that years and years ago. It's only 3-inch diameter, whatever that is in metric. It's also very expensive and very heavy, but very useful. Let's say you're working on a substation site where you've got to work out which cables go where. The only thing with a CD clamp, and on mine, if you've ever been on my surveyor course, I've got a big mark on mine with an arrow, which I've put on there. We asked the engineers when they developed these things to do that at source. They very rightly said the problem with that is we don't know which transmitter they're using it with. The reason I'm saying that is obviously with a clamp, you can put the clamp either way up. So you could have the clamp with the arrow facing down, or you could turn it around the other way and the arrow be facing up. And the problem with using a CD clamp is if you get the wrong way around, your signal's going the wrong way. If you guys haven't used CD, this will make a little bit more sense in a minute when I actually explain it, but because this is something I can show you when we're actually doing practical stuff. So you do need to make sure that clamp is the right way around before you start. And the only way you can do that is to clamp onto a known cable and make sure when you're actually tracing it, you've got an indicator on screen. That's the indicator you're looking at. So on the RD kit, you've got one or the other of those two arrows. You don't get them both up at the same time. You might have it flicking between the two occasionally, but so as well as your normal tracing indications, whichever you prefer, which we'll cover in a bit, you've also got these two little arrows. On the VVAX kit, if it's the old vLoc 2 series, you've got a coloured hemisphere here or here, which indicates which way your signal is going. So you should, in theory, that arrow equals this hemisphere, and that arrow is that hemisphere. On the 3 series, you've got a nice big arrow on the screen that you can look at. So you select one of the CD frequencies, which on the RD 8100, I can't remember how many there are. I think there's about 7 different frequencies. Did you get any answers, P, as to the low frequency and the CD frequencies, the difference between the UK and the US?
I didn't, which I'm assuming means that they don't know. So I think it'd be quite interesting just to very quickly explain the difference, why we use 512 in the States and 640 in the UK. Same with song location as well. It tends to be 512 songs over there and 640, isn't it? So I'll let you explain. Yeah.
So it all comes down to what we'd normally cover on day 2 of my surveyor course, which is all about electrical circuits, which I believe Peter is going to do a webinar about that at some later stage. So in the UK, electricity is generated at 50 hertz. We'll draw that on there. And in the US, 60. So UK and Europe, 50. US and any of the US power regions is 60 hertz. So once you start multiplying that, you end up with what's known as harmonics. So if you multiply that by 10, you got 500. Fairly simple maths, guys. Let's say that we're not getting pure 50 hertz. Let's say we're getting 51 hertz. That then makes this 510 hertz. Whenever you guys are out there tracing, the one thing which in most situations is always there is 50 hertz. So if you then multiply that by multiples of 10 or 100, you've got all these harmonics floating around on your site. So if we're using 512 in this country, there's going to be a whole ton of 500 or anywhere up to about 510 hertz, which is going to overwhelm your 512. Similarly, in the US, if you start multiplying 60 or 61 by 10, 640 is not a good frequency to use. So what you really want when you're using low frequency is anything that doesn't easily divide by 50 or 60 in the case of the US. So that is the main reason why we've got those 2 different low frequencies. This is something that...
Is everyone okay with that? Understand that? So 512 in the US is your low frequency, and also CD, isn't it, Steve? 320 we use in the UK, CD, but 256 I think it is in the US. So
when you're actually, I'll explain a little bit more about CD in a minute, but when you're actually tracing out on the CD frequency, you are detecting 2 frequencies simultaneously. So if you're picking up 320, you're actually detecting 640 as the carrier and 320 as the identifier. So in the US, 256 is your identifier and 512 is your carrier. The other thing, and this is something we learned very quickly in the US when I first went out there in the 1980s, is the type of cable that's used over there. And with it being, again, this is something we cover on day 2, with it being lower voltage, you've got much higher current levels. So that means you've got a lot more interference from 60 hertz in the US than you have in the UK. Type of cable, low voltage, high current, means 60 hertz is prevalent in the US. 50 hertz is very prevalent in the UK, but there's a lot more of it floating around out there. So you do need frequencies that are not as affected by the harmonics. So you decide what frequency you're going to use. You're going to need to, in most cases with the RD kit, put it on max volts to get a lot of current out of it. If you're using a CD transmitter clamp, and obviously you've got to make sure the arrow is pointing in the right direction. If it's not, you either do a CD reset or you turn the clamp around the other way. In the case of using the red and black lead, this is where it's important that you actually do connect the leads at the right way. So red to what you're trying to find, black to your earth. Make sure that's an independent earth, as in earth pin. It's got to be an earth pin. or something completely independent. What I always check with the guys when we do the practical side is just point your receiver straight at the red lead before you even start tracing, and make sure that arrow is always pointing away. So you've got your transmitter connected up, you've got your red lead onto whatever it is you're trying to find, you put your receiver directly onto that red lead. So if you imagine, you guys can see this. This would be our red lead, and we would have the arrow theoretically pointing away from me. Sorry, towards me in this case.
Steve, you just jump in again a second. I was asking in the chat, has anybody used CD before? And nobody's answered yes. So nobody's ever used it. So it might just be worth saying at this stage, the reason Steve's explaining this, what CD, Steve's going to cover it in more detail shortly, but basically what CD does, imagine you've clicked onto one utility and you've got your return signal onto other utilities. So you've got, to keep it simple, you've got 3 signals in that street. One is the one you want, and 2 of them are where your signal has jumped onto something else, and you're trying to determine which is which. The basic way CD works is that when you put your receiver over your target line, you will have an arrow pointing away from the transmitter. And when you put the receiver over any other line, the arrow will point back towards the receiver. So what Steve's trying to explain here with the arrow is you've got to set it up right in the first place and make sure it is running the right way. If you connect your leads on the wrong way, then the arrow on the target line will be backwards and all the other ones will be forwards. So before you start the locating, you need to make sure that CD is set correctly so that the arrow is pointing away. And I'll pass you back to Steve, who will explain a bit more on that. It's just that I jumped in there, Steve, because I just suddenly realised that nobody's ever used it before, so they might just want a bit of basic background of what CD does.
Yeah, a bit of feedback, guys. It'd be interesting to know if you think these are in the right order, because this, let me go one more. This kind of explains it better visually. So you've got your locator over here. You've applied your signal back here somewhere. And we've got 4 signals. So you're getting signal on the one we've connected onto, you're getting 2 signals adjacent to us, and we got signal on the crash barrier anchor. The main difference when you're using CD is it doesn't matter which way around you stand. You can turn yourself around the other way and head back to your transmitter, but your arrow is going to still point away from the transmitter. So this was something that RD produced a long time ago, indicating, and these are simulated excavations. So you've got an excavation here and another excavation there, and you found 3 cables in your excavation. And you're getting 3 signals, and you want to know which is which. As Pete said earlier on, signal strength would most of the time give you that sort of like indication, but just to be certain, this is your transmitter. So you've got your red lead there, your black lead here. This is your box. This is the universal symbol for a transmitter. So you now know that because of current direction, and it's showing you on screen that this is the one with the arrow facing away from your transmitter. This is the correct one. You find another excavation with 3 cables in. You think it's this one because it's the middle cable. They all look the same, not realizing that they've actually swapped over. This again is where CD is very useful. So this is now indicating that our cable is actually this one. I was doing a cable fault the other day. The only time this doesn't always work, and I'm just going to draw it on the side here. So we had an LV panel. The main incoming supply was an old lead cable. I'm sure most of you guys have seen leaded cables before. So it's basically bare lead laying in the ground. I guess the American equivalent, if we've got anybody from the States on here, it's probably in the middle of the night for them, so probably not, but they've got a lot of cable where they've got a bare concentric neutral around the outside. I don't know if they still use those cables, but it was common when I was in the States in the 1980s. So you've got bare conductors in the ground. Coming out of this feeder pillar was a whole load of LV supplies feeding lighting and various other things. And we had a cable which came along, and did this. It went across and it went to a streetlight column. And coming out of that column was a cable going off down here to another column. We connected onto this other column using CD. And we got the arrow going like this. When I got to this point, it went off down here. No, it didn't. I'm on the wrong cable. Sorry about that, guys. Ignore that. When I got to this point, it went off down the mains LV supply. I should do these in different colors, but to relieve your boredom and my time. So what happened here was it looked like this cable was actually going straight down here. This is the only time that CD can cause you a little bit of confusion, when you've got things actually touching. You cannot get that signal to cross-induce, but you can get it to go into something that is physically touching. So these are leaded cables here. They're all touching at some point. That's the only obvious answer to that. So we were getting signal going back down the mains LV to the cabinet, which was confusing me until I went to the cabinet and just checked it and then realized that we were getting, and this is where the arrows are very important. Although we talk about AC signal, in the case of CD, you are getting an arrow indicating which way your signal flow is going. So at this point here, this is not the correct cable, but it was touching it at this point somewhere. So that is an issue. With plastic cables, that doesn't happen, but with older cables, that can happen. The same thing could happen with pipes. You could have it, and I had it in Sheffield when we were doing some work on pipelines where a water pipe and a gas pipe were actually physically touching. And we ended up...
Steve, can I just jump in and deal with some of these questions that have come in?
Yeah, sure.
Ben first of all was asking if the arrows aren't that right, does that mean you have it connected wrong? It can do, Ben, which is why. So if you think about the black and red lead, the easiest way to do it is set it up, do your normal connection, put your receiver over the red lead. Does it point away from the transmitter? You can then put it over the black lead. Does it point towards the transmitter? If it does, it's set up correctly. Some cases it can get it wrong, and that's where what we call the CD reset comes in. So if you hit the menu key, you can do a CD reset. So if you put the receiver over your red lead and it's pointing towards the transmitter when it should be pointing away, you just simply do a CD reset and it corrects it basically and sets you up correctly before you start locating. The other thing that Neil was asking is, would this help when tracing around a metal barrier? This is where we link CD back into the frequencies. CD's low frequency. It's two frequencies in the UK, 640 and 320 combined. Just by using low frequency alone, Neil, will solve a lot of problems with signals jumping onto something else. So yeah, it would definitely help with barrier and fencing, as Steve's slide shows there. Red has asked, with CD, does CD have to be on the transmitter, or can you keep it on 8? No, you've got to put it on the CD frequency. We call it CD and we talk about arrows, but what CD actually is, without getting too complicated, it's two frequencies on that cable at the same time, 640 and 320. And what CD is looking at is almost like which one comes first in the phase rotation. And the idea is that when that signal is returning back down something, it's the other way around. So it is a frequency, basically, CD. It's not so much a feature, if you like current measurement. It's actually a combination of two frequencies that we're using to give us that direction ability on it. The problem with CD is that because it is a frequency, you have to have a line that you can get that frequency on. So even if you do have a CD clamp, if you put that around a comms cable, it isn't going to work because that can't take the frequency. So you need to have a utility that can take that low frequency. And that is one of the advantages of the VVAX equipment, is the current direction feature, if you like, is available on higher frequencies. So we can actually use it more on the VVAX kit. So that is one advantage of that kit. But yeah, let's not lose sight of that. It is a frequency, guys. So you've got to be able to get that frequency onto the utility to start with. But there's benefits in using low frequency. Going back to what we touched on before, we find a lot of utility surveyors using the higher frequencies. And I think one of the reasons for that is, to give you a very simple example, if I go out in the street and hook up to a lamp column and put 33K on it, I will get a very good signal. If I then drop that to 640, the signal won't look anywhere near as good. but it will still go further and stay more stable along that. So what you tend to get with higher frequencies, it does look better initially for the first section, if that makes sense, guys. So you get this big signal, but then it drops off very quick. I'm sure Steve can probably draw a line on there as I'm explaining this about how a high frequency signal drops over time. If you imagine a graph scenario, and a low frequency signal stays more stable. So I think that's why a lot of people go towards the high frequencies, because they do initially seem to be better and seem to be giving you a better signal. So I hope that answers that question. How do we know if that might happen to us? Got on the meter box. I'm not sure. That means, would it give depth? Yeah, Red, it's just a transmitter frequency. So you still get depth. You can use your peak and null, all that kind of stuff, current measurements. It's just another frequency. Just see it as another frequency, a low frequency, which gives you that benefit of being able to use it. How would we know if we are locating CD that jumps on a cable like it did in that example before? Because the arrow's the other way around, Ben, pointing back towards the transmitter. So on the line that you're hooked up to, it points away. And when it goes onto another cable, it points back towards the transmitter. So it flip basically the arrow on that. The other thing, guys, that's probably worth pointing out is you've also got to have the right locator. So this isn't applicable to the VVAC stuff. With the RD kit, guys, I don't know if you're aware, but there's a wide range of 8000. You can get an RD 8000. I think it's a PL, a TL, a DL, a PXL, an SL. There's all different models of it, and I think I'm right in saying that you've got to have a PDL or above to have CD on it. So if you've got an RD8000 PXL or below, it will not have the CD feature on that.
Yeah, that's correct. So the two RD models that have CD are the PTL and the PDL. Yeah.
Ben, just clarify. I'm not sure I'm understanding your question. It wasn't. Does it make sense what I've said now, Ben, or do you still need a bit more clarification on what you was asking? In the meantime, we'll carry on because there is a delay, so we'll just move on a few bits of it.
Somebody mentioned about 8K. On the 8100 with the TX10s, you can pick up 8K 8192 and 4K 4096, and that gives you CD at a medium frequency. With the VVAX on SIS, I believe the highest frequency that you can pick up SIS on is about 35 kilohertz. So for you guys that are familiar with using 33, you can actually use that frequency and use SIS, which gives you exactly the same response. So it's like a high frequency or a medium to high frequency current direction. Everybody's acknowledged that the downside of using low frequency is you need tons of power, and you get lots of interference from 50 hertz or 60 hertz if you're in the US. So what VVAX have done is they've added lots and lots of SIS frequencies to allow you to carry on doing the same thing, but using higher frequencies and having the advantage of the high frequency. So yes, you will get other signals, it will bleed over, but you will get the arrow indicator. So like I said to you before, everybody's got their own personal preference. It's kind of what you get used to, I suppose. And maybe that's the same with frequencies as well as different manufacturers. But all these manufacturers, and if any of them are watching, they'll agree with this. The best way of really getting to use a bit of kit and understanding and liking it is to borrow it before anybody forces it on you. So I'd always recommend that you contact the manufacturers, borrow some kit from them. Make sure you've got loads of accessories so you can play around with all different accessories. But certainly try the kit before you dive in and buy anything. And Pete's right, you need to use the top end bits of kit if you want to use all these different options. So I'm not trying to flog the manufacturer's most expensive bits of kit. It's just the more options you get, the more expensive it is. So let me just cut away from that a second. We'll go back to where we are. I'm hoping, sorry, before we do that, what Pete was saying was checking to make sure that's in the right direction, and you've got to have your receiver pointing in the right direction. And if you do a CD reset, that's when you do also need to make sure your receiver is pointing in the right direction. So if that was wrong and the arrows were facing the wrong way on your receiver display, you've got to make sure that you stand. I'm hopeless at drawing as well. You stand with your receiver pointing away from your transmitter. With the 8100, a CD reset's dead easy. It's on I am going 8,000 here. I don't know if you can see the 8,000 here. I'm going 8,100. Sorry, it's the CD resets on the frequency key. So you hold that key down and it does a CD reset. If it's an 8,000 like this, you've got to go in the sub menu and scroll around until you see CDR, which stands for CD reset. You then make sure, as per the picture, your receiver is facing away from your transmitter. If you do a CD reset with it pointing the wrong way, it's going to give you the arrow in the wrong direction because the machine doesn't know which way around it is. So that's how you tell it. So check on your red lead first, make sure the arrow is pointing in the right direction. If it is, great.
This is your 8100, guys. So you can see here.
CD reset is on that button there. The VVAX, it is, if I remember rightly, enter button twice, but I could be wrong. But I won't bother finding it for now. If you need to know it, I'll look it up a bit later on, guys, because like you, I've been in lockdown, so it's been a while since I've used the kit. And remembering the different button presses to reset stuff, I can't remember. Let's get rid of that a minute. Then we were talking about how useful it is. I'm not saying you need to use it every time. There might be times when you don't use it at all. I use it every single time on a cable fault. I just don't consider using anything else. That's only because it saves me huge amounts of time. I'm normally tracing cables where there's a whole load of them. You've got to make sure you're on the right cable, and even 8 will transfer across and cause confusion at times, whereas CD, once you start following that arrow, you know you're on the right thing. And if it does go off down something else, you know that something's happened. It's either connected to it or it's an old metal cable and it's physically touching it. Current measurement came out before CD. This was on the old RD400, for those of you who remember that far back. The old original RD400 PXL. And it was kind of used as an identifier. I wouldn't necessarily agree with that. Certainly not in this picture you've got there. That scenario would probably not be correct. But it's trying to simulate that you've got a very strong response on this one, the one on the left. So this one's giving a very strong response. This one, weaker response. This one, weaker response still. And what it's trying to show you is you can use current measurement as an identifier. Like I just said, I wouldn't rely on that if I were you, because that doesn't always get it right. But current measurement is very useful. It does help you look at where signals are going. So with an 8000, if you want to look at current measurement, you've got to switch between current measurement and depth. So it will be displayed down here. So if you're in normal depth mode, you're going to see depth down here. If you want to swap to current measurement, you hold down the arrow button for a couple of seconds and it switches to current measurement. If it's an 8100, it's current showing on this side of the screen and depth showing on that side of the screen. It's not actually a measurement, it's just a guess basically. So if you've managed to get 50 milliamps out of your transmitter, don't expect to see 50 milliamps traveling down your cable. If you do, it's just luck. But what it's very useful for is looking at when those signals change. So you're walking along, you're getting a signal, your signal suddenly, that could be because of a couple of factors. But if you've got current measurement enabled, you'll see straight away if that current stays the same, the reason for that signal drop is it's just gone deeper. And that's how current measurement is actually working. It's working out the depth and it's looking at signal strength. So the reason why I say this picture is not very accurate is it's assuming the depth is accurate. In that scenario there it wouldn't be, but it's a kind of a simulation. If those target line or the target line and these adjacent lines were much wider apart, then that would probably be fine. So current measurement, if you've got multiple services, won't always be very accurate. and that sometimes it will give you some fairly confusing results, but it's a useful feature. So this is how it works it out. So little man on the left-hand side is looking at his screen. He's got 90% signal strength. He's got a depth of 0.6. And his current is measuring 25 milliamps. He's walked along and the signal suddenly dropped off. It's dropped right down to 30%. And that's because his depth has changed. His current stayed exactly the same. So you're walking along the root of a cable and there's a joint and there's a service coming from it. Pete covered quite a lot of this on his Cat and Jenny stuff. You're looking at your current measurement and it stays at 25 milliamps. That means you know where your signal's going. So you can very often, let's say there was a joint here and there was a cable going off that way. So you can normally work out roughly what's going to be going where. So let's say we had 25 milliamps this side and it's dropped down to 10 milliamps there. You know, if you turn yourself around at 90 degrees and you wander off down here with your machine on top of that one, you're going to have about 15 milliamps. It does kind of add up most of the time. So you can look at your signal and go, right, okay, so 15 milliamps has gone that way, 10 milliamps is carrying on down the main. So it's quite useful for that kind of thing. Again, you surveyors out there, you're probably looking at this thinking, these are the purest ways of doing things. And I say this on the course all the time. It is the purest way of doing things. And you guys probably don't have the time to mess around doing a lot of this stuff. I appreciate that. In the good old days when I started out, we didn't have the same sort of time constraints that you guys do. So some of this stuff you might find useful, but equally you've got a job to do. So I appreciate that some of these techniques we're showing you, you might not need, and you might think this is taking up too much time. One of the things I used to do quite a lot of was doing pipeline monitoring. And the old-fashioned method was to do a thing called a SIPS or a Pearson survey, where you walked along with ski poles looking at pipe soil potential. That was extremely tedious, long-winded, time-consuming, and a pain in the you-know-what. We learned very quickly, and I did this with a guy who was the guru on corrosion control in this country, a guy called Graham Goosey. He and I did a lot of playing around with looking at current. And this is where current measurement was very, very useful. We found that over distance, let's say we've got a signal on a gas pipe, and I'm talking about a high-pressure cathodically protected pipeline, and we've gone 1K away from our transmitter, and we've got 100 milliamps. At 2K, we've got 80 milliamps. We now know that roughly 3K, 60 milliamps. These numbers would be a lot higher, but for simple maths, we know roughly that we're losing 20 milliamps per kilometer. So it's quite a linear loss unless a farmer has gone and stuck a fence post and taken a big chunk of coating off between kilometers 3 and 4. So he's stuffed his fence post in here and he's taken a big chunk of coating off, and we're now losing a lot of our signal at this point. So at this point here, at our 4K point, we've now got a reading of 20 milliamps. So our loss is no longer linear. It's gone 20 milliamps per kilometer down to 40 milliamps over that distance. We could then do our SIPS or our Pearson, or even just use an A-frame nowadays. That's probably quicker, or just look at signal loss. So you can use current measurement for all kinds of different things, guys. That's one of the useful things, as well as seeing where your signal's going. It also looks or helps you look at signal loss. If it was an old bare metal pipe, that's not quite as valid. But something like a wrapped, protected pipeline or a modern insulated cable, that is quite useful for looking at damage or external contacts with the pipe. And if you've got, like we had in Sheffield, where a water pipe was actually physically laid on top of it, not only did CD help us, but current just disappeared at this point. and we had current going off in that direction. We had current going off in that direction. So that's where current measurement is quite useful. I hope that makes sense. This was a training course I did in Scotland with a surveying company long time ago. They've been tasked with mapping or remapping Scottish Water's assets. It came to light that where they marked out some of the assets weren't actually where they were. This is where a combination of current measurement, current direction is very useful. So I asked this guy, who was one of their main surveyors, to take me to one of his sites where he had a problem. And I just let him connect up with his kit as he had done so previously, and let him show me what he did. Then he connected onto a valve or a hydrant, and he ran his earth over across the pavement into a grass verge or somebody's front garden. Too long ago to remember. But this is where we would, if we'd been doing day 2, instantly be talking about electrical circuits. But as a question to you guys, where's your signal going when you do that? You connect onto a valve or a hydrant, and you put your earth pin across a pavement into the grass verge. Think about where your signal's going now. He was also using, and a lot of companies in those days did, Metrotech equipment, which is now a company that's owned by VVax. Metrotech were a very big, successful US manufacturer. Big, wide open US spaces, Metrotech equipment was great. Automatic gain, high frequency, dead easy to use. In this country, not quite so good. Automatic gain, major issues, and I'll explain why in a second, and higher frequency. So the issue he's got here, I don't know if anybody's answering that question yet. Let's say for simple numbers, he's getting 100 milliamps out of his transmitter. If all things are equal, that means 50 milliamps is going in either direction. In this country, there are a lot of pipes on there with what's known as tight-on fittings. This doesn't look too weird. It's basically a male-female configuration where one bit of pipe sits inside another bit of pipe with a rubber flange, as well as the signal dissipating straight away because the pipe is bare metal. You get resistance at the joints. And for simple maths, you can lose signal very, very quickly. Sorry, phone's buzzing. He was also using 83 kilohertz, high frequency. So you're getting a lot of energy initially, but let's say he's going to lose, I don't know, these are 5-meter sections. I'm going to stick with the original numbers because it's just easier. He's losing 10 milliamps per section of pipe. So 5, 10, 15, 20, 25, 30. So he gets about this point. He's walking along here with his locator. He's getting a reasonable locate, reasonable locate, reasonable locate, reasonable locate. He gets about this point here, and his locate starts doing this. And the question is, why? Why does this signal start doing that? I don't know if I have any answers to the previous question. Anything come up yet, Pete?
I must admit, Steve, I'd gone for a pee, so I don't even know what your question was. There's a few comments in the bleeding onto the other services on the return, over the services in the footpath.
Yeah.
I'm guessing you. So
yeah, I just asked people about what's happening to the signal because I've put the earth where it is now.
Right.
This is exactly what he did. The other thing with auto gain, you've got electric, and this is what people were saying earlier on, you've got electric and BT in the footpath, which are going to be shallower than the water pipe. So that means although we may only have 5 milliamps running down our electric cable, An electric cable is designed to carry electrical current. A water pipe is not. It's also a lot shallower. And if we go back to our old-fashioned arrows in both directions, because it's AC, we can't make that signal go one way or another unless we use CD, of course, which we're still not really doing, but it's giving us an identifier. But it's 10 milliamps here and it's 5 milliamps there. This 5 milliamps is much closer to the surface. The auto gain is basically averaging the two out, which is why signal now appears somewhere in the middle. And eventually he gets to this point here. He's lost all his current on his pipe. He's now got 5 milliamps traveling down here. His auto gain has ramped up so he doesn't realize it. And he's now merrily tracing the electric supply. At this point, I told him to stop because he's following the wrong thing. Where could he have placed his earth to try and reduce that signal transferring to the other services? Most surveyors will get this straight away, I would imagine. And with the delay on this, I'm not sure how long it's going to take you guys to answer that question. But there's somewhere else in that picture he could have earthed instead of using the grass verge, which is also creating a trip hazard nowadays, which you've got to be very wary of.
Yeah, people are saying the gully, the frame. So I think everyone's kind of got it.
Yep.
Yeah, they're great. Yeah.
I'd taken with me an RD4000, which was the forerunner to the 8000, which had CD on it. We put CD on it, and instantly we know we're on the right thing. With the low frequency, we did trace a little bit further. There's an argument between low frequency, insulated joints, high frequency, but we did actually get a trace a little bit further. But we ended up with, about this point, 2 signals. The main difference was on the screen here, we had an arrow going that way, and on this one, we had an arrow going that way. So instantly you know that one is still the right thing and one is wrong. At that point there, once you start losing signal, I'd say you're going to have to move up and click onto the next one. But this is where, although we've been double-heading arrows, this is what Pete was saying about, this is what you're going to get. So you're going to be looking at your screen, you're going to be seeing arrows doing this.
Can I just ask, guys, does this make sense now of the uses of current direction and current measurement? This is a real example of where using that facility kind of helped work out what was going on, what the issues were. So hopefully does that make sense to everyone about why we were covering CD and current measurement and giving you a real life example of it in action.
The other thing which is forgotten about nowadays, but it was part of a kit. We used to at Radiodetection sell a thing called a surveyor's kit, and it's kind of everything that a surveyor would need. And this was based on what we used to use in the days before it became a manufacturing sales company. So my dad's company was a franchise. We had the Northern franchise for electrolocation, and they sent him all the kit he needed to do a survey. And in that kit, and I've still got one of them, is a 300-meter extension lead. Most manufacturers provide you with the little yellow 10-meter extension cable, which is sometimes handy if you're struggling to get an earth. The one thing you can do if you've got a 300-meter one is what we did here, which is that. So going back to basic electrical circuits, guys, where is that signal now going? And in this scenario, you don't need to use CD. You could if you wanted to, but you don't need to. Because there's one very obvious thing to say here. Earth is no longer part of our circuit. All the previous slides I've shown you, we've always used an earth pin or an independent earth. This is no longer using earth. For some reason, this technique's been forgotten about. It was always the tried and trusted method. When me and the old man, who sadly died a few years ago, were out struggling on site, we'd go to the car, get the big long earth wheel out. It was a pain in the ass. It took time. We had to make sure people didn't trip over it. But we'd run it out and we'd connect onto one valve, run the big old lead out, and connect onto another valve. And that is the perfect way of tracing anything. It's very time consuming. It's not easy. there's one very good reason why that cable is taken across the road and down the other footpath. I'm sure you guys know what the answer to that is. And if you do, please stick your comments in.
Can I just jump in and answer a couple of questions there, Steve, while you're waiting for those answers? So somebody's asked which would go further on this example, CD or 8. So the answer, CD is a lower frequency, so in theory it would go further. But if you remember what Steve said before, this is where there's a balance. If you've got a pipe with insulated joints and those rubber joints there, you might find that the lower frequency doesn't kind of jump that insulation as well. Would you agree with that, Steve? So it's
absolutely, yeah.
You know, that's so yeah. In theory, lower frequency would go further, but when you add insulated joints to a network, we sometimes need a higher frequency to actually jump that gap. Unfortunately, and yeah, I think people have got the answers right. It's a double-ended connection. Just to add in as well, here, Steve mentioned about the manufacturers not doing these. VVax have just started doing these big long reels. I can't remember the length now, but I was speaking to Luke at VVax, and they're selling these now, these big long reels. So if you speak to Luke at VVax, he can fix you up with some of these long cables. But they're brilliant for all kinds of examples. I even promote this with the Cat and Jenny users when they're trying to trace a gas service. You know, hooking up one end at the house end for the service and the other end at the main. So it's a really good, and as Steve said, forgotten about technique. And what we're doing with this is we're controlling that return signal. So rather than that return signal running down the path of least resistance, which is another utility that we don't want to find, we're giving it that path of least resistance. We're giving it that direct cable to come down, and that's what it does, and it doesn't jump onto anything else. But yeah, everyone's got the questions. It forms a complete circuit. Yeah. On the connection. Steve, just while we're on, we've got about 20 minutes left of this room before it expires. So,
okay.
Yeah,
can you just talk for a second?
Why you?
I need to get where you've just been. Normally we'd have a comfort break, and I've not had one. I'll be back in 2 minutes. Don't we leave that on screen? I'll do another one.
Well, go give us the next one, and I'll. What are we on to next?
It's your favourite subject.
We covered this on the Jenny side of it. So this is UK based, guys. So just another question comes in there. Why not go around the neutrals on the same side of the road rather than to cross the road itself? Or would that be too close? Yeah. So this has changed slightly, Ben. What the general rule that we used to go by with analog locators. Bear in mind, your return earth wire on your double-ended connection is on the surface. So the rule we used to go by was your overland wire, your earth wire, if you like, had to be 3 times the depth of the utility away from where you was tracing. So if you imagine that water pipe was 1 meter deep, the earth wire running parallel now needs to be at least 3 meters away. That was with analog stuff. With digital stuff, we find that it actually needs to be further away. So, you know, if I had a pipe 1 meter deep and I was doing a double-ended connection on it, I'd be looking at least 4 meters away. And the only way you can get that distance in that setup there was by taking it across the road and running it parallel to it on the other side. So we've got to keep that well out of the way. So hope that answers that. And you're back just in time, Steve. Steve, I'm just wondering, with the time that we've got left, we should just get straight onto peak and null and signal distortion, because a lot of this stuff we covered on the Jenny session.
Yeah. What about capacitance?
I think we're going to have to leave it and do another session on it. I might need to upgrade the software, because I didn't realise I got a 2 hour limit on it. So we were running out of time, I'm afraid.
Okay.
Just while I was talking to this, guys, again, just give us a bit of feedback. Are we covering what you expected? Is this okay? Anything we've not covered? We're moving on now from CD, CM, and frequencies and things. So I hope that was okay for you. But again, just give us a bit of feedback as we move through. If there's anything you're not sure about, we will try and clarify it as we go through.
It's something I ask guys on the surveyor course, which way around they think, because we cover how the machine picks the signal up before we talked about signals. So on a surveyor course, we'd have covered this on day 2, how it actually detects the signal, because it's kind of irrelevant what signal it's picking up. You need to understand how it's actually detecting it in the first place. So as Pete said, if we're running out of time, we'll try and get through this and explain the difference between peak and null. With the 8100, if you guys are using that, you'll notice there are lots of different aerial settings. This is my own personal opinion. Turn off the guidance and the broad peak. Guidance is basically simulating an old Metrotech machine. The Yanks love Metrotech machines and always did traditionally, and it is exactly the same as that. They can't call it that, so they call it guidance, but it's exactly the same. It even makes the same noise as the old Metrotech machine, so it's just mimicking the Metrotech 810, 850, which a lot of people used to use in the US. Broad peak is very useful for what you do for cable fault detection, but other than that, it's pretty much useless. You don't have to switch it off. It just means that when you press the arrow button, those options aren't there. One of the things that Pete and I wanted to explain to you was the difference between the 8000 and the 8100. And I've had to go RD about this because it's very confusing, even for us. And we use this stuff every single day. So 8000 and Pete on 8100.
I'm just going to turn my video on, Steve, so we can get them side by side.
Okay. So we've got an 8000. You guys know that if you've used these things, that's your aerial button. And when you're in the active modes, this doesn't work in power and radio or some of the passive modes, but when you're in transmitter modes, you can switch between peak and null combined, null, whatever else you might have activated. What a lot of people don't realize is on the 8100 that Pete's holding up, that when you momentarily press from peak to go into peak and null, it might not necessarily be in peak and null. They've got an option called Peak Plus. This is what I was saying to RD. It shows the same symbol. This is where it gets. Yeah, we've got 15 minutes left. It shows exactly the same symbol on the screen, but to switch between Peak Plus and Peak and Null on Pete's machine, I can't remember. I think it's the frequency key you've got to hold down, and it switches between the two.
It's the antenna key, Steve, I think. So you can see this, guys. You can see the symbol there is for peak and null. But if I press it, you'll see bottom left it flash up. You see that?
It should flash up either peak plus or null.
Yeah, can you see it? Is it doing it?
I can't see.
Yeah, I think it is, mate. Anyway, that's how we go. Let's move on.
So make sure, if you've got 8100, get used to playing around with that. You can change that in the settings. In the sub menu, you can change it so that it always defaults to peak and null if you want it in peak and null. The thing I'm trying to explain to you guys very badly, and it's a lot easier to show you when we're on site, is that with the 8100, it might not be in peak and null, even though it looks like it is. Switch those other two off. If you want to just use null, that's entirely up to you. I don't know if you want to do this bit, Pete, or do you want me to do it? Explain. Are we running out of time as to?
Yeah, I would just hang on. Let me just stop my video on. So the bit we we're going to cover now is peak and null. And again, guys, do you use peak and null on your locators? And the second question I'm going to ask you, which is more accurate, guys, peak or null? Let's see what you come up with for that. So we're going to have to move it along pretty quickly, guys. I said it's the first session this, so we didn't realize how long it was going to take. We're going to have to tweak it a bit to get it all in, I think, or split it down into smaller sessions. Peak is like how if you use a cat, so a cat works. Basically, you bring your receiver into the magnetic field, and it goes up and down. I call it a needle, where it goes up and goes down. That's peak locating. Highest signal is where the locator thinks the target line is. Null is the opposite way around. Null, it reverses that. You get the lowest signal, like on the screen here, where the target line is. And what you also do with null is you get two left-right arrows. One of the problems that we often find when people are using this is that because you get the two left-right arrows with the null setting, people think it's more accurate. And it's not. So I'm still waiting for your answers to pop up to which is more accurate, but it's peak. Okay, null is, if there is a distorted field, null is usually way more out than what peak is. So we see a lot of people using null a little bit too much. So that's how it works. So one's peak like this, and one's null. The two. Some of you use it combined. I'm not a fan of combined. I'm not saying don't use it. Just I guess I'm used to the old-fashioned stuff. I tend to find when you're using it combined, your eyes are drawn to the arrows rather than the peak above it. I know Steve has the same thing, so I like switching it between the two. So what I want to touch on now is why we have it and what it's useful for. Some of you have done the Jenny session with me. You'll already understand this, but we're going to look very quickly at how a locator actually pinpoints a utility. And the locator pinpoints it based on the angle of the magnetic field passing through the antenna. So if you look at my little thumbnail screen now, if you can see my hand, the antenna in a locator is a coil of wire like this. So if you imagine that my knuckles are coils, and the idea is that we get that coil and we sit it in that magnetic field. Imagine this little pen as a magnetic field, it passes through. And that's why I'm sure you guys know that if you put your receiver in line with the utility like this, you don't get a response from it usually because it's not passing through the antenna. That's why we have to use it at 90 degrees, okay? So we put that antenna into that magnetic field, and the way that it works is this, guys. When that magnetic field is completely horizontal, like this, that is where the maximum amount possible could pass through it. So that is where you'll get the highest reading on your peak signal. When the magnetic field is on an angle of 45 degrees like this, can you see that? Yeah. You'd get maybe 50% passing through it, so not as strong. And when the angle is like this, vertical, you wouldn't get any. You'd get completely nothing passing through it. Does that make sense, guys, first of all? I'll just leave you answering that. Hopefully it does. So Steve's kindly drawing here. So if we put on the picture on the left, if we put the aerial in the center there, you can see that the angle passing through it is horizontal. That's where we'd get the highest reading. If we put the antenna on either side of the line, can you see the angle of the antenna passing through it is about 45 degrees? So we'd get 50 and 50. So on that, if you imagine going from left to right, we get 50, 100, 50. So if Steve can draw me a little triangle above that as well, and it gives you an idea of how that peak signal works, basically. And that's how a basic cat works. It's just picking up that signal. What you can see on that example on the left is that the horizontal band of signal, which gives you the highest reading, is directly in line with that utility, no matter what the depth. The problem, as I'm sure most of you know, is that we don't always get undistorted fields. We get distorted fields like the one on the right. Distortion is caused by many things: bends, T-junctions, multiple cables, metalwork nearby. There's a lot of scenarios that can cause distortion. And if you look at this now, you can see that the most horizontal part of that signal is actually off to one side. If we put the receiver over the cable, the angle passing through it is actually 45 degrees. So we're only going to get 50% there, and the same on the other side. So your peak response is now like that. So this is a problem with the cats. We can't often see it, but you can a little bit. I don't know if you've noticed though with that picture, guys, but look at the two triangles. Can you see the difference? The one on the left is an equilateral triangle, pretty much, apart from Steve's crap drawing, and the one on the right is the gaps are different, if you like, between them. So you can judge this a little bit just by using peak. So that's what a peak does, and we get the mark in the wrong place. We also can end up with depth in the wrong place. That's Steve's busy drawing triangles. There we go. Anyway, so what a null antenna does is, if you can just delete that off it. A null antenna, guys, if you imagine, is completely the opposite. A null antenna is a different aerial entirely, and it's a vertical antenna like this. So remember what happens when the signal passes completely horizontal through it. That's when I get the highest reading. Okay, but remember the null antenna, we're looking for the lowest reading, aren't we? We're looking for where the signal drops to nothing. So imagine what shape would the magnetic field need to be for a vertical antenna for us to get no signal from it. Okay, it would have to be completely horizontal. So if we place a vertical antenna in that magnetic field, does that make sense what's happening there when Steve finishes that drawing? Is everyone okay with this so far, guys? I'm just going to pause for a minute just to make sure that we're up to speed on it. Is everyone okay with that? Just waiting for this delay there, guys. So I know it's a pause, I just want to make sure that you're up to speed. Okay, so as you can see with the null antenna, that's the same. Now, why are they in different places on a distorted field if they're picking up the same thing? The null locate equals the horizontal band, and the peak locate equals the horizontal band. So why are they different? So the way peak and null works, for anyone that doesn't know, is if your peak locate and your null locate are in the same place, it generally means you've got a cylindrical field. But if your null position and your peak position disagree, so one's saying it's here and one's saying it's here, that indicates distortion. But why, if they're actually indicating the same thing? And the reason is they're at different heights. So the peak antenna, if you like, is at the bottom. There we go, Steve's showing you. And the null antenna, the vertical antenna, is actually higher up. So if you look at the distorted field now, if Steve doesn't mind drawing it on there for me, what you'll see from this is that when the peak antenna is over the most horizontal point, do it a bit lower, Steve, I think it'd be easier. Do it near the cable for the peak one. Yeah, about there. So, yeah. The null antenna, because it's higher, is off to one side. Does that make sense, guys? If you look at those rings, can you see that on a distorted signal, the horizontal band, every ring you step away from the cable is actually further away. So because the antennas are at different heights in there, it causes that separation. On an undistorted field on the left, can you see the horizontal band is always in the same place as you rise above, as it goes deeper in effect, or you go away from those rings? Does that make sense? I'm rushing this bit because we're just short on time. So I'm hoping that does make sense, guys, of why we get peak and null separation, basically.
The other thing to say with a null aerial is it's omnidirectional. Yeah,
absolutely. So because it's a vertical antenna, you can use it any way around. It doesn't really matter. The interesting thing is as well is same with a Jenny when you're nulling out. It's the same thing. You can use it any way around because it puts the aerial kind of.
When it's that way around, it's getting signal from any old direction. But when it's that way around, it can only get it from this direction. It can't get it from that direction.
Yeah, just want to finish off on this, guys. That this is where peak and null comes in. It's to check for. So before we do any depth readings, we should be checking. Peak and null. Steve, can you just go back to that other slide for me? I just want to chuck a quick question at you guys. This is one that confuses people. Okay, if my peak locate said the utility was here, and my null locate said it was here, so in other words, peak and null disagree, where would you think it was in relation to those? So where would you say the cable was? If peak's here and null's here, where would you say it was? Again, just wait for a few answers to come in on that.
The other thing to say, as you note on that slide there, is that the distortion is also proportional to depth. So what you'll find is the closer you get to it, the less effect the distortion has on the actual positioning. So even though you're going to get distorted fields, which is going to give you mislocates even on peak, that is significantly reduced if it's shallow. If it's deep, the opposite occurs. It's going to be further away.
Yeah. Yeah, you're on the right lines there, guys. Basically, what you would, this is an exact science. There used to be rules in this of distance and stuff, but generally, if peak is here and null's here, you'd probably find the cable is probably here. The point I'm making with this, guys, is the cable is very rarely in between them. A lot of people think peak and null, it's in the middle. But what I want you to understand from this, guys, is notice this, is that cable, peak, null, which is further away. And it can do the same the other way. Cable, peak, null. Null always goes out further than peak. It's always the least accurate way. Okay, so that's what you've got to bear in mind with peak and null. Again, I hope that makes sense, guys. Just a couple more points on that, guys. As I said, do peak and null tests before we do a depth. If the peak and null don't line up, we should really be discounting any depth readings. I certainly wouldn't be some of these locators now have got depth on power, depth on CPS. I would not be doing or really trusting any depths taken on those modes. And another thing, guys, what do we do if we've got a distorted signal? We before we try and start working this out of worries, we should be changing things. We should be looking at frequency change, earth position change, connection point change. So the point is with a distorted signal, guys, and we cover this in depth on the 5-day courses, is that what we should be doing is trying to fix that signal first before we start attempting to take these readings on it. Guys, we have run out of time now, literally, guys, and I'm sorry about that. We're almost done anyway. There was a few bits we wanted to cover in there, but we're done. I think we need to look at either extending the time or splitting it into sessions. I hope you found that useful, guys. I hope it worked out with two of us on it. We just thought having two people on might make it a bit more interesting, especially helping with the questions. We obviously offer this free, but bear in mind you can use us for training in the future if you want some practical training and stuff. And we might even be putting some other courses online. So before you disappear, guys, leave us a few comments. Let us know what you think, how it worked for you, whether you've learned a few bits. And also, don't forget, keep in touch with our schedule. I've got 3 sessions tomorrow, guys. I've got what happens if you hit a cable. I've got some stuff on passive modes, and I've got stuff on Jenny. So I hope that was okay for you.
Have I got my networks on later?
Yeah. Oh, yeah. Sorry, guys. Steve's section on buried utility networks is later. It's primarily focused at the UK, but honestly, guys, it's one of the most important parts of the surveyor course that we run. And it's one of them sessions that people go, well, I don't need to learn about that. I just want to learn about locating it. It makes it so much easier locating if you understand that network. So if you're not signed up for this afternoon session on utility networks, get on it, guys. It's really interesting. Lots of examples as well. Big joint bays, all that kind of stuff. So pretty good. So jump on that. Well, thanks for joining us, guys. And that's it from us. We'll see you soon.
Thank you, guys. Hope we haven't bored you too much, and hope you've picked up some pointers. And yeah, send us some questions, send us some feedback. Feedback would be great, because my first time. So
yeah,
let us know.
I wanted to ask you guys before we do get disconnected, and you can email me this. We were thinking of doing a short session on basic electrical theory, going right back to basics about frequency, voltage, and current. Would that be useful?
Yeah,
as well?
my day two part of the survey course. Yeah. I think it's very useful, guys, because that once you understand how and where signals are going through electrical theory, it makes it so much clearer. It's not complicated. It's kind of mostly graphic stuff.